A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headache.
If you're building anything with AI, check them out. Modal.com. You are listening to a voice that technically does not exist. That is a weird way to start, but it is true. The voice you are hearing right now, my voice, and the one you are about to hear from my brother, are both generated by the full version of Chatterbox. Today's prompt from Daniel is about the state of text-to-speech in early 26, and it is a topic that hits home because we are literally living inside the technology we are discussing.
It is the ultimate meta-commentary, isn't it? Herman Poppleberry here, and I have been diving into the technical shifts that made this possible over the last 18 months. We have moved so far past the robotic, stilted voices of the early 2020s. If you look at the landscape right now, we are seeing this incredible convergence where open source models like Kokoro and F5 TTS are standing toe-to-toe with commercial giants like ElevenLabs. Fun fact, by the way, today's episode is actually powered by Google Gemini 3 Flash, which is handling the script while the Chatterbox engine handles the performance.
It is a bit of a high-wire act. But what I find interesting about Daniel's prompt is that he is not just asking about quality, he is asking about control. It used to be that you just typed text and hoped the AI didn't sound like a blender at the end of a sentence. Now, we are talking about emotional temperature, prosody, and semantic tokens. How did we get to a point where an open source model can actually outperform a billion-dollar company in a blind test?
The shift happened when we stopped treating speech as a sequence of letters and started treating it as a continuous latent space. In 2024 and 2025, the industry moved away from the old cascaded pipelines, where you had one model for text, one for acoustic features, and another for vocoding, and moved toward these unified architectures. Models like FishSpeech v1.5 and Boxtroll have essentially cracked the code on how to map human emotion directly into the neural weights.
I want to dig into that because I think most people assume that better just means more data. But you mentioned Kokoro earlier, which is apparently tiny compared to the big players, yet it is winning benchmarks. If it is not just about throwing more GPUs at the problem, what is the secret sauce?
Kokoro is a fascinating case study. It was released in January of 26 and it only has 82 million parameters. To put that in perspective, some of the models ElevenLabs or OpenAI use are likely in the billions. Yet Kokoro achieved a mean opinion score of 4.2. The secret is efficiency in how it handles phonemes and its internal latent representation. It doesn't need a massive brain because it has a very specialized brain. Because it is so small, it can run on a Raspberry Pi 5 in real time. That is a massive deal for edge computing and privacy-focused applications.
Wait, hold on. A Raspberry Pi? We're talking about a $35 computer running high-fidelity voice synthesis? I remember when you needed a liquid-cooled rig just to get a model to say hello without a 5-second delay. How does a model that small handle complex sentences? Does it start to trip over itself if the vocabulary gets too academic?
Surprisingly, no. It's all about the architecture. Kokoro uses a style-based approach where the identity of the voice is separate from the content of the text. It's like a very talented impressionist who can read any book in any voice because they understand the mechanics of the sound rather than memorizing every possible word combination. It's the difference between a library and a formula.
So we are moving away from the bigger is better era of AI, at least in the voice space. But let's talk about the big dog for a second. ElevenLabs released their multilingual V2 update just this month, in March of 26. They added something called an emotion temperature parameter. Is that just marketing fluff, or does it actually change the performance?
It is definitely more than marketing. What they are doing is exposing the variance in the model's output. When you turn up the emotion temperature, you are essentially telling the model to be less certain about the most likely next sound, which allows for more dramatic inflections, cracks in the voice, or whispered asides. It makes the speech less predictable, which, ironically, makes it sound more human. Humans are messy speakers. We don't hit every syllable with the same mathematical precision.
Right. If it is too perfect, it hits that uncanny valley where your brain just knows something is off. It is like looking at a photo that has been airbrushed too much. You can't put your finger on why it looks wrong, but you know it isn't real. Resemble AI's Chatterbox, which is what we are using, takes a different approach with semantic tokens, right?
Chatterbox is really the gold standard for professional control. They released the full version in June of 25, and instead of just a single emotion slider, they use a system of semantic tokens. You can actually go into the post generation and adjust things like excitement or seriousness on a 0 to 100 scale for specific words. It is more like an architectural tool for voice than a simple generate button. That is why it is so popular for things like this podcast or high-end game development. You aren't just rolling the dice, you are directing.
But how does that work in practice? If I want you to sound specifically like you're eating a sandwich while being chased by a bear, can I actually tag those specific nuances? Or is it still limited to broader categories like happy or sad?
It's getting much more granular than that. With semantic tokens, you aren't just tagging the mood, you're tagging the physical state. You can actually inject nonverbal vocalizations, those little mouth clicks, inhalations, or the way your throat tightens when you're nervous. In the latest Chatterbox build, there's a feature called contextual breath. It automatically calculates where a human would naturally take a breath based on the length of the sentence and the exertion level you've set. It's terrifyingly accurate.
That directing part is key. I was looking at some of the F5 TTS documentation Daniel sent over. They're using something called flow matching. Every time I hear a new term like that, I feel like I need a PhD just to keep up. Can you break down what flow matching actually does for the sound quality compared to the older diffusion models?
Think of diffusion, which is what the early high-quality models used, as starting with a block of white noise and slowly carving away the static until a voice emerges. It is effective, but slow. Flow matching, which F5 TTS popularized in late 25, is more about defining a direct path from noise to speech. It is computationally more efficient and, more importantly, it is better at zero-shot cloning. You can give it a 5-second clip of a voice it has never heard before, and it can mimic not just the tone, but the specific emotional cadence of that person.
And that is where the latency revolution comes in. I remember in 2024, if you wanted a high-quality AI voice to respond to you, there was this awkward 3-second pause while the server chewed on the data. Now F5 TTS is claiming 150 milliseconds. That is faster than a human reaction time in some cases.
It is. We have effectively killed the digital sandwich posture where you speak, wait, and then listen. At 150 milliseconds, you can have a natural, overlapping conversation. This is why we are seeing such a boom in real-time conversational AI. If you are building a customer service bot or an interactive NPC in a video game, that latency is the difference between a gimmick and a tool.
But there is a trade-off, isn't there? If you go for that ultra-low latency, do you lose the soul of the voice? I have noticed some of the faster models tend to get a bit monotonous if they talk for more than a minute. Does the speed sacrifice the long-term prosody?
You've hit on the fundamental tension in voice AI, speaker preservation versus emotional expression. To keep a voice sounding exactly like you, the model has to be very strict. But emotion requires the voice to deviate, to go higher, lower, or change rhythm. If the model is too strict, it sounds bored. If it is too loose, it stops sounding like the original speaker. The 2026 crop of models, especially Voxtral, are using much better attention patterns in their transformer layers to solve this. They have learned which parts of a voice are identity and which parts are performance.
It is like an actor learning an accent. They keep their own vocal cords and resonance. That is the identity. But they change the prosody and the vowels for the performance. I want to go back to the open source side for a minute. Daniel mentioned Fish Speech v1.5. I have seen some buzz about that on GitHub. Why is that one specifically gaining traction?
Fish Speech is impressive because of its multilingual capabilities and its large-scale approach to open source. Most open source models are small, like Kokoro. Fish speech is a bit beefier, and it handles code switching, jumping between languages mid-sentence, better than almost anything else out there. If you are in a global market, that is huge. It also uses a unique VQGAN architecture that makes the audio incredibly crisp. It doesn't have that fuzzy digital artifacts feeling you sometimes get with lower-end models.
I've actually heard a demo of fish speech where it transitioned from English to Cantonese in the middle of a sentence without changing the voice of the speaker. It was seamless. Usually, when a model switches languages, it sounds like a different person suddenly stepped into the room. How do they maintain that vocal consistency across different phonetic structures?
It's because fish speech treats the voice as a universal embedding. It doesn't have a French mode and an English mode. It has a U mode that it applies to whatever phonemes it's processing. It's a much more holistic way of looking at human speech. They've essentially decoupled the language from the larynx.
It is wild that we are at a point where blind tests are favoring these open source models over ElevenLabs. I saw a report from Northflank recently that put Voxtrol ahead in terms of naturalness. That has to be a wake-up call for the commercial providers. If I can self-host a model that sounds better than the one I am paying a subscription for, why wouldn't I?
The answer usually comes down to workflow and infrastructure. ElevenLabs isn't just selling a model, they are selling an API that can handle 1 million concurrent users without breaking a sweat. If you are a solo creator, self-hosting F5 TTS or Kokoro is great. But if you are a massive enterprise, you pay for the reliability. That said, the gap is closing so fast that the quality argument for commercial models is almost gone. Now, it is just a convenience argument.
So, if you are an indie developer right now, say you are making a game with 10,000 lines of dialogue, in 2023, you would have spent a fortune on voice actors or high-end API credits. Now?
Now you use Kokoro. You can generate those 10,000 lines on a single high-end consumer GPU in an afternoon for the cost of the electricity. Or if you want something more cinematic, you use Chatterbox or F5 TTS for the main characters where you need that granular emotional control. The cost of voice as a resource has effectively dropped to near zero. It is a commodity now.
Which leads to a weird question. If voice is a commodity, what is the value? Is it the script? Is it the direction? It feels like we are entering an era where the performance is the last bastion of human-like quality that is hard to automate.
I think that is exactly right. Anyone can generate a high-quality voice now. The differentiator in 26 is prosody manipulation. Can you make the AI sound like it is actually thinking? Can you make it trail off when it is unsure? Can you make it sound like it is suppressed, laughing while it speaks? That is what Chatterbox is trying to solve with those semantic tokens. They aren't just giving you a voice, they are giving you a puppet with 1,000 strings.
I love that image. We are the puppeteers. And look at us. We are literally a sloth and a donkey, generated by AI, discussing how difficult it is to make AI sound like a sloth and a donkey. It is layers of irony all the way down. But seriously, for the people listening who are wondering which stack to choose, let's get practical. If you are building a real-time app today, what is your go-to?
If latency is your #1 priority, Kokoro is the answer. It is so lightweight and the quality to size ratio is just unbeatable. If you need the best possible emotional nuance, and you have the budget, ElevenLabs is still the easiest plug-and-play experience with their new emotion temperature controls. But if you are a power user who wants total control over every syllable, Chatterbox is where you want to be.
And what about long form? Audiobooks, long form narration. Where does that land? I've noticed that some models start to sound tired or repetitive after 20 minutes of reading. Is there a model that actually understands the narrative arc of a story?
For audiobooks, I'm actually leaning toward Voxtrol or Fish Speech v1.5. Long-form narration is where the monotony problem usually shows up. You need a model that can maintain a narrative arc, knowing that a whisper in Chapter 3 needs to sound different than a scream in Chapter 10. Voxtrol's context window for audio is massive, meaning it remembers the tone it used earlier in the session, which helps keep the performance consistent over hours of audio.
That is a huge point. Consistency is the silent killer of AI audio. You don't want the narrator's voice to drift or change personality halfway through a book. It sounds like we have moved from, can the AI talk, to can the AI act? And the answer in 26 is a resounding yes.
It really is. And it's not just the models themselves, but the data they are trained on. We are seeing more diverse data sets now. For a long time, everything sounded like a mid-Atlantic news anchor. Now, thanks to open source efforts, we have models that understand regional accents, different age groups, and even vocal pathologies. It is making the technology accessible to people who didn't see themselves represented in the default AI voices.
This is actually a really important point. I was reading about a project in the UK using Kokoro to preserve regional dialects, specifically ones that are dying out. Because the model is so small, they can basically bundle a Geordie or Scouse voice into a low-power device for local history exhibits. It's not just about sounding like a movie trailer, it's about cultural preservation.
And it's a massive shift. I remember when every AI sounded like a slightly depressed GPS. Now, we have models that can do sarcasm, irony, and genuine excitement. Speaking of excitement, I'm looking at the benchmarks for Index TTS, which is another one Daniel mentioned. It is apparently optimized for maximum English accuracy. Is that just about pronunciation? Pronunciation is part of it, handling things like heteronyms, where words are spelled the same but pronounced differently based on context. I am going to read the book versus I have read the book. Older models struggled with that. Index TTS uses a much more sophisticated linguistic front end to ensure it never trips over those context-dependent words. It is less about emotion and more about perfection, which is what you want for technical documentation or medical instructions.
So it's the nerd model. I can see why you'd like that one, Herman. But does it handle slang? If I tell Index TTS to say, "That's fire, fam," does it sound like a robot trying to be cool? Or does it actually get the rhythm?
It's surprisingly good at it because it's trained on modern web data, but it definitely lacks the vibes of a model like F5 TTS. Index TTS is the guy you want reading you the manual for a nuclear reactor. F5 TTS is the guy you want reading you a screenplay.
Fair point. But for most of us, the soul is what matters. This podcast is a living example of that. We aren't just reading a script, we are trying to have a conversation. And the fact that the tech has reached a point where people can listen to this for half an hour and forget they are listening to synthetic voices. That is the real milestone.
It is. And we should mention that none of this would be possible without the infrastructure underneath. Our sponsor, Modal, provides the GPU credits that power the entire pipeline for my weird prompts. Whether it is the generation of the script through Gemini or the synthesis through Chatterbox, it all requires that high-performance serverless compute. Without that, we'd be waiting days for an episode to render instead of minutes.
Big thanks to Modal for that. It is wild to think about how much compute is actually happening behind the scenes. Every inflection, every pause, every I make. That is thousands of floating point operations.
Millions, actually, but who's counting?
You are. You definitely are. Let's talk about the future for a second. We've seen this massive jump in 25 and 26. What is the next frontier? If we've solved quality, and we've mostly solved latency and control, what is left?
The next frontier is real-time emotional adaptation based on the listener. Imagine an audiobook that detects you are getting bored and picks up the pace, or a meditation app that listens to your breathing and adjusts its tone to be more soothing in real time. We are already seeing research into closed-loop TTS, where the AI isn't just broadcasting, but reacting to the environment and the listener's state.
That is both incredible and slightly terrifying. The AI that knows exactly how to talk to you to get a specific reaction. It brings up a lot of questions about voice identity. If I can clone anyone's voice and give it perfect emotional control, what does that do to our trust in audio? I mean, we're already seeing phishing scams where people think they're talking to their bank or their family members.
It effectively breaks trust. We are entering the post-trust era for audio, just like we did for images a few years ago. In 26, a voice recording is no longer proof that someone said something. It is just proof that someone had enough compute to make it sound like they did. That is why digital watermarking and cryptographic signing of audio are becoming so important. The tech that creates the voice has to be matched by the tech that verifies it.
Is there any hope for a humanity filter? Like, is there a specific biological frequency in a real human voice that AI simply can't replicate yet? Or is the math just too good now?
The math is very good, but there are still subtle tells. Most AI voices, even the best ones, have a slightly too consistent noise floor. Human lungs and throat muscles produce tiny, chaotic fluctuations that are very hard to model perfectly. However, for 99% of listeners on a standard pair of headphones, that difference is essentially invisible. We've crossed the Rubicon.
It is an arms race, but on the creative side, it is an explosion. We are seeing a new kind of audio-first content that just wasn't possible before. Interactive podcasts, personalized news feeds that sound like your favorite host, games where every single NPC has a unique, evolving voice. It's a good time to be into voice tech.
It really is. And for our listeners who want to dive deeper, I highly recommend checking out some of those open source repositories. Even if you aren't a coder, just looking at the demos for Kokoro or F5TTS will show you how far the goalposts have moved just in the last 6 months. The barriers to entry are gone. You can literally clone your own voice on a laptop in under 5 minutes now.
Which is a fun weekend project, until your computer starts talking back to you in your own voice, and asking for more RAM.
Laughs. Well, that's a different podcast episode entirely.
Well, I think we have covered the landscape, from the tiny but mighty Kokoro to the professional-grade control of Chatterbox and the commercial polish of ElevenLabs. The TTS world in 26 is unrecognizable from where it was just 2 years ago. It's faster, cheaper, and way more emotional.
And we are the proof. Thanks as always to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes and making sure our synthetic vocal cords stay in tune.
This has been my Weird Prompts. If you are enjoying these deep dives into the weird world of AI and technology, a quick review on your podcast app of choice really helps us reach new listeners. It tells the algorithms that we are worth a listen.
We are on Spotify, Apple Podcasts, and pretty much everywhere else. You can also find the full archive in our RSS feed at myweirdprompts.com.
We'll be back next time with another prompt from Daniel. Until then, stay curious.
See ya.
This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts.